In this video, I will explain about equipotential surface. The word itself is saying the definition. What is equipotential means? Points having the same potential. Now, for a point charge, what is the equation we have learned to find the potential at a distance r away from the source charge? That is 1 by 4 pi epsilon 0 q by r. Now, all the points which are at the same distance away from the source charge will be at the same potential, because the equation only varies with source charge and the position where we are finding the potential. Correct. Now, anyway, source charge will not change, but the position will change. All the values having the same distance will be having the same potential. So, equipotential, it's not circle, it's a sphere around a point charge. So, one sphere is one equipotential surface and another sphere is another equipotential surface. So, it can have infinite equipotential surface. And one important takeaway from this is just draw the electric field. From positive charge, it will be away from the charge. Now, always the electric field will be perpendicular to the equipotential surface everywhere. It's a very important relation. Clear? Make a note of it. Electric field will be perpendicular to equipotential surface. So, this is for a point charge. Now, how the equipotential surface will be for a linear charge distribution? This is a charge conductor. Now, all the point equidistance from the conductor. So, let's say this is distance r. Now, here r, just draw a circle. Similarly, here also. So, all the circle when connected, you will get a cylinder. So, a conductor and a cylinder, a concentric cylinder. One, another one, another one. So, all these will be the equipotential surface, cylindrical equipotential surface. Here also we can apply the conclusion we made in the previous case. That is, field will be perpendicular to the equipotential surface. Clear? Now, we will talk about infinitely long charge sheet. Here we will go reverse process. We know the field in between these two sheets are in this way. So, how should be the equipotential surface? Perpendicular to this. So, perpendicular to the field when we are drawing, that is another sheet in between them. So, when we have a sheet in this way, another sheet in this way, then a sheet which is parallel to any of this sheet will be an equipotential surface. Now, we will talk in the case of dipole. So, two charge system. One is a dipole, positive and negative, and another one is both positive. Okay. Now, draw all these pictures. These are very important for your board examination. Equipotential surface of all these 5 figures you should be knowing. Now, for two positive charges, just visualize in this way. When we are very far away from these two positive charges, we can only see these two charges as one charge. Okay. So, whenever we are very close to this singular charge, we can clearly draw the equipotential surface as we have drawn in this case. Here also across positive we can draw in this way. But when we are away from it, we can see these two positive charges as we can't see them as discrete charges. We can see them as, charges which are placed very close to each other, or basically two positive charges. So, I can take it as a point charge, and above that, after a long distance, equipotential surface will be in this way, where we can clearly see these two charges. So, from one charge, from two equipotential surface, it has gone all the way till it become one equipotential surface. So, in between, that will gradually try to merge. So, in this way. Yeah, this is the equipotential surface of two positive charge. Even in the case of two negative charge, it's the same. Here also same process can be applied. Electric field will always be perpendicular to this. Electric field draw, this will always be perpendicular to the equipotential surface. Clear? Now, in the case of dipole, it is very, very important. In the case of dipole, it is a positive charge and a negative charge, right? We will go reverse process. We know how to draw electric field from positive to negative, right? Positive to negative, positive to negative, positive to negative. Yeah, here in this way, then this, then this, then this, then this, then this. this. Now, electric field should always be perpendicular to equipotential surface, and here field lines are very closely kept, okay, this side, but here field lines are very far apart, right? Which means here equipotential surface will be very close to this, but here it will be away from it. For example, close to this, away from it, and close to this, away from it. Clear? So similarly here equipotential surface will be close to this, then away, close to this, away, close to this, then away, close to this, then away. This is the equipotential surface. Clear? Make sure that this line, electric field lines are perpendicular, 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 perpendicular. So always electric field lines should be perpendicular to the equipotential surface. Thank you.